you know those things. So today I'm going to, if I finish this, which I will, you can do all the question of the homeworks. Nine. Homework 10 or nine? Nine. Okay. This one, let's see that we have a simple RL circuit, okay? Remember, after this, we switch to sinusoidal signal. That's why I asked you review your sine wave that you have the first year of college or even in the high school, okay? Now, let's consider this simple RL circuit that you have a sinusoidal force with a magnitude VF, omega is angular frequency, okay? And I want to see that even this simple loop, if I want to analyze in a time domain, you see that how much is going to give you a problem. And that's the reason we're going to switch later to the complex domain. Okay, let's apply KVL here. When you say the R times I plus the voltage across the inductors, which is L di to dt, is equal to the source voltage, which is Vm cosine omega t. So you have basically the first order differential equation, okay? So if I want to solve it and I calculate I of t, I need to solve this differential equation. Now, imagine instead of one loop, you have several loops, and you have capacitor, inductors, and you have few loops. Then how hard going to be the analysis in time domain? You're going to have equations, so many equations in the form of integral differential, and we need to solve them, which is almost impossible. So for time being, just very fast, we are not going to use this technique when you're working with AC. But to do this homework problem, you need that, and to do the sum of the phasor, we need that. Okay, so if I have this differential equation, very fast I'm going to derivation because I'm not checking you on differential equation. We are just interested in the steady state solution, okay? Not the transient, not the exponential function. We just are, when we're doing the sinusoidal, we just want to calculate a steady state or what the
So that's the
particular
final,
function,
right?
final solution. Final. When, so that's why we say the circuit is on the sinusoidal steady state condition, because that's what we assume, that your transient solution goes to zero already. Okay, so we are looking for final answer. Okay, now we, like all the math, I assume that my final answer or a steady state solution or force response is have this general form: I1 cosine plus I2 sine. I don't know what is I1 and I2. The only thing I know, whatever is the omega here, always all of the solution going to have the same frequency. So frequency doesn't change. Okay. So what I do, I substitute this equation in this solution in your differential equation. Okay. So we have Vm cosine omega t is R times I plus L times I prime. Okay. And when I do that, I'm going to factor cosine omega t and sine omega t and equate their coefficient with this. In the right-hand side, I just have, in left-hand side, I just have cosine omega. So basically, you're going to get equating the coefficient of the cosine. Coefficient of the sine, you have two functions, two equations, I'm sorry, with two unknown, and I solve for those two unknown, okay? So this procedure is this. You don't need to really go through all this, okay? Because there is impossible to do this kind of thing. Just for a proof, we do it. So you apply KVL, You have a differential equation. You assume the steady state solution. You substitute this in differential equation. And with the sum matrix, we find I1 and I2. After we find it, we substitute in the solution. Okay. When I do that, your response comes to this equation, which is, oh, you don't see it or you see it? Do you see that? So it's come here. You got the I1, I2, you substitute here, and that's your answer. There is a mistake in the note, cancel that R. You see that very simple RL, this is my current, okay? Now, the key is here because later on, we just always need to know the magnitude and the angle of your output. I'm going to change this to this forms because we have to do it later next class to do change to the phasor. So your response always you want to write as a one cosine function. Okay, the question is, if I say I want to equate this to this form, I want to calculate the A and theta using the cosine law. Now you need to, from here, you need to listen carefully because you need for your homework. You can write this. You say cosine omega t, cosine theta, sine omega t, sine theta, correct? You expand it. Then you're going to equate the same coefficient of like cosine omega t here, cosine omega t. So your A theta is going to be equal to this function. You have sine omega, sine omega. So your A sine of theta is going to be omega L divided to this, which is on the next page.
Professor,
Yes.
why did you cancel the R on the last
Oh,
line?
because it was wrong, because I
Oh, okay.
put R inside. R was inside.
Okay,
So I
thank
put it twice. That was mistake, typing mistake. Okay, so I want, when I did equate them, you come with this two equation. And I need to find A and theta. How we get the A? You can square the both sides and add them. When I square both sides of this equation and this is equation, and I add it, and I factor A square, your cosine square plus sine square is equal to what?
1.
1. So from here, you just get A. So that's my A. To get the theta, I divide these two together. A sine theta over A cosine theta is tangent of theta. So your theta is an inverse function, correct? So doing all these steps, that 2 page, I got my A, I got my theta, and I put in this equation. See, your I of t was A cosine omega t minus theta. So we got A, we got theta. So the solution of this simple RL circuit, after spending 2 page, see, 2 pages, is come to this. Okay? Come to this one. On the problem of the homework, just for this homework 9, you're going to use this. But later on, we're going to have this analysis is going to take 2 minutes instead of 2 pages. It's 2 lines, okay? But you need this for the homework 9. So this is this current in that RL circuit. And the purpose of this to showing you why we go to complex domain, because just for one loop, if I want to calculate the current, is you're going to have 2 pages minimum to get the answer. Okay. Now, let's just go to this equation. You're going to use this equation in the problems for RL circuit. Now, If in this equation, my R be zero, if you have no resistor, you just have a source and inductor. So R is zero. Let's see what happened to your angle. What is the inverse cosine of infinite? When R is zero, your theta come to 90 degrees.
90.
And when L is zero, when you don't have inductors, when N, L, or omega is zero, your theta is zero. So pay this that when you just have one inductor, one inductors, just L, okay? Your current and your voltage, the phase angle difference is 90. So inductors, the current through the inductors, add the voltage across it by 90 degrees. See the current here, the theta, the phase angle difference between my voltage and current is what? 90 degrees when you just have one inductor. So inductors, the current through it and voltage across it have 90-degree phase difference. For resistors, if I just have a resistors, there is no phase angle difference. Just keep this thing because voltage is just RI. So whatever is the angle of voltage, the angle of current is the same. Now, for inductors, because of that J, later on you're going to see, we will have what? Phase angle difference. But keep that in your mind. Okay. Now, there is, because we don't have that much, if imagine I solve this equation and now in the math, you will see they give you this in the homeworks. This is similar to homework problem. They give you this and they ask you, this is my voltage, is this coefficient cosine plus sine. And they ask you, find the amplitude and the phase angle of the V of t. So it means that change this to this format. So similar to what we did, we say we expand this is a cosine omega t cosine theta plus sine omega t sine theta, and you equate to this equation, correct? Now, comparing these two, your a cosine theta is what? 0.8055. Your a sine theta is 1.341, correct? This is important example. You need that things because we need to learn how to change to phase. Okay. Now you want to find A and theta. You do the math trick. You, like previous, square this, add them. So you can get your A from here, correct? Your A square is this. Do you all know that?
Yes.
Okay. And you get the tangent of theta by dividing these two together. So you got your theta. So now my voltage is there. So my voltage V of t is a cosine function with this amplitude and this phase angle. Is that clear? So now you know all kind of homework problem. You can do the homework problem. That was, I was want to rush through it. So is some of the problem is like this, or the complex numbers. For complex numbers, last time I told you read the appendix, correct? And which I also there is in my note on the review. And also I want to do one example, this one, the same thing we did a few minutes ago numerically. Okay, so imagine I give you this RL circuit, like in the homework, you have it. This is your source is sinusoidal. See, remember, if it wasn't sinusoidal and it was just 230, you short the inductor, no? That was before. But now we have a sinusoidal. So the voltage here is there, you know, you can get the current by integrating this. Now you have the R, you have the L, you have the source. So my Vm is 230. Your omega is what? 50, no? Because remember, your Vs is Vm cosine omega t. So your omega here is 50 radian. You have your N, you have your R. The question is find the I of t. So what you're going to do, I put it the answer, but you're going to use this equation. The solution which we got on the previous page is Vm over divided this. You have the Vm, you have the R, you have the L, you have the omega, correct? Everything. So you substitute in this equation and you get the answer for the current. Is that clear?
Yes.
You don't, we use these things for homework 9, but you don't need to memorize this, okay? Because we're going to go easy way later. Okay, now, the question is that, what is it, current is lagging the voltage or leading the voltage with which degree? Okay, now, how are we going to do that? I got my current is this. Your voltage phase angle is what? 0. So the phase angle difference between these two is pi over 6 or 30 degree. So the current and voltage here, they are out of phase and the phase angle difference is what? 30 degree. Any questions so far? Now, if they say how many seconds, what is the phase angle difference between the current and voltage in second? You will go here. You say my omega t is 30 or pi over 6, correct? Omega t is pi over 6. So what is the omega is? 2 pi f, no? Remember? Or you can solve it for t from here and you get your, because I substitute for you here. See, your omega t is 50t, which is equal pi over 6, the phase angle, correct? So from here, your omega is equal to 2 pi f, no? I'm sorry, you got your omega t, 50t, and you can solve it here. From here, you have the pi, you have t, you can solve it for t. This is faster. You divided this and you get in the second. And you don't need to substitute. You have omega t, pi over 6. So your t is pi over 300 or 10 over 46 seconds, millisecond, which I got that. Okay, so the phase angle difference between voltage and current, if they ask you, is 30 degree or 10.47 seconds. Any question here? Any question? Okay, let's see on the chat if there is a question.
No, there wasn't any questions.
Okay, no question. Okay, thanks. So this is just the beginning of this chapter. This chapter, phasor, is easier than what you did until now. I promise you.
Professor,
Yeah, if you know complex numbers, okay? Yes.
how'd you get 30 degrees?
Pi over 6, the angle difference. My voltage was Vm 230 cosine of 52. What is the angle, phase angle here? 0. What is phase angle here? Pi over 6. Pi over 6 is equal to what? The 30 degree, no?
Oh, okay.
I think he's saying, he's saying that I think when you solve for the inverse tangent of L omega over R,
yes,
equal to pi over 6.
Yes, you get that pi over 6 when you put
Oh, okay.
So what I really want you to do, if you want to get a good grade here, believe me, for this section, the circuit, I know all of you know mesh, all of you know nodal by now. The only thing maybe you will missing is start working with your calculator to do the complex number, how to add, so this homework 9 even is all math, but is very, very helpful for you. For those of you miss these things, or forgot, or you are not fast on it. So work with your calculator, do your problem homework 9 yourself. Don't copy even if you have it, please. Okay, any other questions? I don't want to start the phasors because these are the appendix. Remember, we did these pages, which is, I reviewed for you complex numbers last time. So there is another example here, how to add and divide it. Another example here. So, or read the appendix, read my note, read your book, whatever is help you. Try to work with your what is it? Your laptop, not laptop, calculator. Okay. So I'm not checking you on complex numbers, but you're going to have in a 1 week a matrix with the element is complex numbers. So you need to solve that matrix, which is the element is complex number. So you have to be fast on it. Is that clear? 2020 be different. Taco Bell be hitting what the so you guys listen to each other?
The chat is for everyone, or you could send private messages.
I know, but don't chat these things now, okay?
Everybody's expressing all over there.
I give you some time because then I have to go there and read it, and then I read Taco Bell and all those things. Okay, so I know it is hard for you this semester, same for us, but I really want you to learn the material, okay? So I'm trying my best. Let's help each other. We get out of this Corona season good. So hopefully you all pass with a good grade. And I'm going to go to the Zoom meeting now with the Senate to see what they finally decided. Some of the campuses just give the pass or no pass, or they ask it even to give to a student either A or B or C. So you guys are lucky, maybe not the NF. So let's see what's going to happen, okay? But whatever it is the result, try to learn the subject because even
Ace for effort.
Yeah, because if you are electrical engineer, you need it until end of your life. You are mechanical, you are computer engineer, you want to pass, get your license, this course, you need it for your license.
For the FE.
Yes, for PE exam, for EIT exam. They changed the name of EIT exam?
I don't think so.
It's the same name, yeah?
Yeah, but most people go with the FE now in the PE.
Yeah, PE exam and
unless
all
you're
that.
engineering and training. I mean, that's not really a popular exam though.
Yeah. So, and I really want you to learn the subject. I do my best. I'm trying. And I'm sure you are doing it because I see you, all of you are attending and listening, and actually more interactive now than in the class, which I like it.
Yeah.
Okay, so take care, have fun. I'm going to end the meeting if you don't have any questions.
No questions.
No question? Okay, bye. Have fun. Go to your Taco Bell. Okay, bye.